Welcome to the National Atmospheric Release Advisory Center, located at Livermore National Laboratory in Livermore, California. NARAC is a scientific support center that predicts the effects of hazardous materials released into the atmosphere. NARAC's computer model predictions help protect people and aid emergency preparedness and response efforts in the US and around the world. Industrial and transportation accidents can release radioactive material, toxic chemical material, or other hazardous material into the atmosphere. For example, damaged reactors in nuclear power plants can release radioactivity. Other threats include explosions of nuclear weapons and radiological dispersal devices, sometimes called dirty bombs, which can cause both blast damage and fallout of radioactive material. During incidents like these, hazardous material can rapidly spread over large areas and populations, causing health risks that range from minor to life-threatening. Furthermore, emergency responders need to know what the hazards are in an emergency zone to ensure that they can provide maximum help while minimizing their risk and exposure. The Department of Energy, DOE, established NARAC to help answer important questions during these potentially dangerous events, and to help emergency responders protect people during these types of incidents. During an emergency, local, state, and federal government agencies need fast answers to these important questions. What areas are affected? Are people in immediate danger? Are they at risk for long-term health problems? Do they need medical treatment? Should people shelter in buildings or evacuate the area? NARAC assists in answering these questions by providing predictions of the areas affected by the airborne plume and the potential health impacts of that plume. At NARAC, a team of scientists predict the hazards. These scientists come from fields like atmospheric science, physics, health physics, chemistry, mathematics, computer science, and engineering. During an emergency or an exercise, these scientists quickly go to work in the NARAC Facilities Operations Center. They use weather data, incident information, and an advanced computer modeling system to map the spread of hazardous materials in the atmosphere and its effects on people. Before an incident ever occurs, NARAC uses advanced computer modeling tools to provide detailed analyses of airborne hazards that can be used to inform emergency plans. NARAC scientists assist multiple national and international government organizations with emergency planning, real-time emergency response predictions, and detailed studies of the effects of atmospheric releases of hazardous materials. They also conduct research and development on software systems and computer modeling tools to continuously improve their ability to help. The center develops simpler emergency response plume modeling tools that users outside of the center can run themselves. These tools provide fast initial predictions during an emergency and are used for emergency planning before an incident. NARAC's computers run an advanced software system with numerous computer models that are used to predict how hazardous materials spread in the atmosphere and to estimate the downwind effects. NARAC stores and continuously updates worldwide weather databases as well as global geographical information such as terrain elevations and population data. When there's an incident anywhere in the world, NARAC software automatically extracts the weather and terrain for the area around the incident. That data is used to build a three-dimensional, that is 3D, model of the Earth's surface and to simulate the flow of turbulent air that could affect the dispersion of material. This simulation includes a model of the effects of complex wind patterns that can change rapidly with time, with height above the ground, and from location to location. The wind flow fields, the small arrows, and information on the hazardous material are fed into the computer models that simulate the atmospheric transport, diffusion, and deposition of the hazardous gases or particles. That's the red dots. Finally, NARAC scientists create maps showing areas that are potentially hazardous due to contaminated air or ground. Areas in red are places where there are immediately life-threatening effects, while areas in yellow are places where there are longer-term health risks. The software system is highly automated. Initial hazard maps and reports are available within minutes so that they can be used in time to help guide emergency decisions. The final maps that NARAC provides to emergency responders and government officials can show a wide variety of information, including areas where different levels of air and ground contamination are expected, estimated radiation dose levels, expected health impacts from exposure to radioactive, chemical, or biological material, blast damage zones, estimates of the number of people affected, and expected number of casualties. The maps also show emergency actions, such as sheltering in place or evacuation, that need to be considered in each area near the emergency epicenter. Just like any emergency response team, NARAC scientists, engineers, and technicians prepare and practice for emergencies before an incident ever occurs. They maintain the global geographical data and continuous flow of worldwide meteorological data. NARAC collects more than 6 million weather observations per day, along with huge volumes of weather model forecast data from the U.S. National Weather Service, Air Force, and Navy. The center's staff members continuously monitor, test, and maintain their software tools, computer models, computer systems, and networks, so they are available 24 hours a day, 7 days a week. Battery backup systems and gasoline-powered electrical generators are in place to provide electrical power if primary power is lost. The NARAC team regularly helps train responders on how to use NARAC tools and products, and they practice with responders and government officials during emergency drills and exercises. NARAC scientists and technicians are always on duty or on call 24/7 to respond to an emergency. Each year, the center supports over 100 emergency drills, exercises, and incidents, and provides thousands of computer model simulations. When an actual incident occurs, center staff members quickly assemble to analyze incident information and field data and produce hazard zone maps. They quickly distribute hazard maps, along with reports on the model simulations and potential emergency actions, through web-based tools or other information systems. U.S. or international emergency operations centers and teams that are responding to an incident can quickly access the hazard predictions to help them make decisions on how to best protect the people affected. The center supports over 20 specialized regional, national, and international nuclear incident response teams, 40 nuclear facilities and specialized emergency operations centers, 300 other U.S. federal and state government organizations, 40 countries and international organizations, and thousands of online users. During an incident, NARAC works closely with other organizations to receive their field measurement data. As more and more field measurement data comes in, NARAC scientists update their modeling assumptions and predictions to better match these data, and to provide more and more accurate model predictions. The refined models can provide predictions in areas and times for which measurements are not available. The center was the brainchild of Department of Energy and LLNL visionaries who recognized that there was a need to understand and predict the movement and health impacts of airborne hazards. In the 1970s, these NARAC founders saw that this was a problem that a national laboratory could solve, and the center has been responding to emergencies ever since. In 1979, the center's first emergency operations began when it was called upon to respond to the 3 Mile Island nuclear power plant accident in Pennsylvania. Using a new computer modeling system, Livermore scientists generated plume prediction maps to guide the Department of Energy field and aerial measurement teams, and to help guide state and federal officials who were determining the potential impacts from the radiological material released from the plant. NARAC was the first operational center in the world to use complex terrain 3D wind and airborne plume dispersion computer models. Using the Livermore supercomputers of the time, current weather databases, and models of human response to radiation dose, NARAC was able to provide near real-time predictions of airborne hazards. In 1986, the worst nuclear power plant accident in history occurred at the Chernobyl plant in what was then the Soviet Union. NARAC's 3D modeling system was used to track the radioactivity as it spread regionally in many directions over Europe and then around the world. NARAC used environmental measurements in Europe and computer model simulations to provide the first estimate of a large release of radioactivity from the Chernobyl plant, which was later confirmed. In 2011, DOE activated NARAC after the earthquake and tsunami in Japan severely damaged the Fukushima Daiichi nuclear power plant. The center operated 24 hours a day, 7 days a week for many weeks, providing hundreds of predictions. These predictions were used to help guide government decisions on how to best protect emergency responders and the public, including U.S. citizens in Japan. Increased contamination occurred in areas of Japan where precipitation scavenging removed radioactive particles from the air and put them onto the ground. NARAC predicted the increased contamination areas, which were also shown by measurements. Because plant conditions and emissions were unmeasured and unknown, DOE and the government of Japan used environmental measurements combined with model predictions to provide the only way to estimate the amount of radioactivity emitted from the plant. The center was also asked to predict the very low levels of radioactivity that were transported across the Pacific. In 2014, when a small amount of radioactivity was released at the waste isolation pilot plant in New Mexico, the plant and DOE asked NARAC to predict the potential downwind effects of the radioactivity. Using on-site weather observations and regional weather models, NARAC simulated the dispersion of airborne particles emitted from the plant and predicted the radiological dose for different areas. These predictions were used to show government agencies and the public that radiation dose levels were below levels of concern, even for long-term health risks. NARAC predictions were verified using environmental radioactivity air sample measurements. Where there were no available measures, NARAC predictions were used to predict the expected radiation dose. These are just a few of the incidents that NARAC has supported during its history. Today, the center continues to build on its original vision, focusing on both operational emergency response as well as related research to continuously improve operational tools. This work is enhanced by strong partnerships with other organizations in the US and around the world. NARAC scientists conduct research to develop new models that can be used to make more accurate predictions, using more fundamental physics and higher resolution simulations. They develop next-generation atmospheric flow models, explosive cloud rise models, as well as rainout and fallout models. Researchers are incorporating uncertainty quantification and probabilistic and ensemble methods in weather and plume model simulations so that they can predict the range of possible outcomes. And they are testing computer models using historical and new field experiments. NARAC staff regularly update the operational computer systems to take advantage of modern software technologies, advances in computer models, as well as the increasingly large volumes of geographical, meteorological, and field measurement data. The center is moving towards higher performance exascale computing, higher fidelity models, an increasing array of higher resolution data sources, and advances in mathematical and statistical techniques such as artificial intelligence. In the future, the center will continue to develop and improve advanced training programs to ensure NARAC staff and user expertise. The center will continue striving to provide the best support possible to users, sponsors, and partners. And most importantly, NARAC will continue helping to protect people by providing accurate and easily usable predictions of airborne hazards. Thank you very much for listening to this summary of NARAC's mission and how it strives to fulfill that mission. Additional information is available at the website narac.llnl.gov.